Okay, so today we will talk about the next machine learning algorithm. Okay, the support vector regression SVR. And I have to start by telling you that the model we are about to implement today, okay, will be slightly more advanced than the models, okay, we have built before. So why is it slightly more advanced? That's because we will have to play a lot with feature scaling. Okay, you will learn how to use feature scaling, how to apply the feature scaling transformation, and also how to apply the inverse transformation to revert data back to its original values. So we will work on the same data set, okay, we used, okay, in the previous session. Okay, features in this data set have known linear relationship. So level and salary have known linear relationship. And in the last session, if you remember, okay, we plotted a chart, right, to see relationship. Okay, and we saw the relationship was curved. In this data set, the position level is going from 1 to 10. Okay, 1 to 10. And the salary is going from 45,000 to this is 1 million. We will train a support vector regression model today to learn and understand the correlations between these position levels and these salaries. Now let's build the support vector regression model on this data set to see if it performs better than the polynomial regression model, okay, which we covered in the previous session. So let's go to the Jupyter Notebook and implement it. So this is the whole structure of the implementation. Okay, importing the libraries, importing the dataset, feature scaling, training the SVR model on the dataset. Okay, we will train this model on the entire dataset. Predicting a new result with SVR model, visualizing the SVR results low resolution and visualizing the SVR results high resolution. Okay, so this is the actually the structure of this implementation that we are going to implement today. Okay, so step one is importing the libraries. Okay, so we will be importing NumPy as NP, pandas as PD, and matplotlib.pyplot as PLT. Run this cell. Okay, we have imported NumPy, pandas, and matplotlib.pyplot. Next tool in this implementation is importing the dataset. So add a new cell and use pd.readcsv to load data from the file, CSV file. So pd.readcsv and input the file name. So the file is contained in a folder, that is data folder in my system, data, and file name is position underscore salaries.csv. This is the file name. And assign this dataset to dataset variable. Run the cell. Okay, cell executed successfully. It means data has been loaded. Okay, now we have data in dataset. Add a new cell, and to verify the data has been loaded successfully, okay, you can use head function. So dataset dot head and supply a number, okay, to specify the number of records, okay, that you want head to show. So we want to see 10 records. Run this cell. Okay, so this is the data. Okay, data has been loaded successfully. So we have three columns: position, level, and salary. Okay. Now, next step will be extracting matrix of features and dependent variable vectors in separate variables. Okay, so currently we have this data in data set. Now we want this data in two entities, in two separate entities, X and Y. So add a new cell, dataset dot ilog. We want all rows and only this level column. Okay, so starting from second column, one index, all columns excluding the last column. Okay, so it will give us only level column. All rows starting from second column, one index, exclude the last column. So starting from level, excluding salary, we will be getting only the level. Okay, dot values. And assign this to X. Similarly, we can create second entity, Y, dataset.ilog, all rows. Okay, we want only the last column, salary column. Okay, in Y. Now run this cell. Okay, so we have extracted this level, this feature, and X, and salary, this vector, and Y. Add a new cell. Okay, and print out X and Y both. Okay, to see what is there in X, what is there in Y. So print X. Okay, so this X is matrix of features, and there is only one feature, level, position level. There is only one feature, this position level, 1, 2, 3. Okay, 1 through 10. Okay, and print Y. And this is vector. Okay, 1D array. So we have values from data from this salary column. Okay, in this vector. Okay, so now we have this data. Okay, in two separate entities, X and Y. X is a matrix of features, and currently there is only one feature, position level, and Y, which has values from salary column. Okay, which is our dependent variable. If you remember, we plotted the data points, okay, using the scatter function to see the relationship between the position levels and the salaries. Okay, and we saw in last session that the relationship is non-linear relationship between X and Y. Next step is feature scaling. Feature scaling. Because if you see here, position level is going from 1 to 10. Salary is going from 45,000 to 1 million. So this salary is far higher than this level 1. This is 1, level is 1, salary is 45,000. Level is 10, salary is 1 million. Okay, so this salary is far higher than the position level. It means these values needs to be scaled. So in feature scaling, we will scale both the position level and salary. So in this data set, the salary is way higher than the feature position level, and the feature might be neglected by the model because the position level values are very small, 1 through 10. Okay, so this feature position level feature values might be neglected by the model. It means, okay, and in this for implementing this feature scaling, this currently the Y is this y is 1D array. This is 1D array. And the feature scaling requires 2D array. So before applying feature scaling, we need to transform or reshape y, because y is 1D array. Y is currently 1D array, but feature scaling expects what? 2D array. So if you input 1D vector y, okay, this will return an error. Okay, so this we need to transform y into 2D array. We can do this transformation in this section itself here. Okay, so to transform this, we can write y dot reshape, okay, and specify the number of rows. Okay, there should be the same number of rows as the number of elements in this vector. Okay, so there are 10 elements in this vector. Okay, so there should be 10 rows, okay, in 2D array. So length of y. So here we are specifying the number of rows as first parameter. The first parameter is the number of rows and second parameter is the number of columns. Okay, so here it should be 1. Okay, we want this to be transformed into 2D array. So in that 2D array, number of rows will be equal to the number of elements in this vector, and this one second parameter is the number of columns. So there will be 1 column, and assign the result to y itself. We are transforming y and we are assigning the result to y itself. Run this cell, and if you print y again, okay, you will see that print y, and now if you see that, see this y is 2D array, right? Now in feature scaling section, let's implement, okay, write statements to implement feature scaling. So we will be using standard scaler. Okay, we to scale values in position level and salaries. So from scikit-learn dot preprocessing scikit-learn dot preprocessing import standard scaler. Okay, we will use standard scaler, okay, to scale position levels x and y, position levels and salaries. And here, because we have two entities, x and y, two separate entities, x and y. Okay, x is already 2D array. Okay, here this x is 2D array and y was 1D array. After this transformation, now y is 2D array. Okay, y is also 2D array after this transformation. And to scale these two entities, x and y, okay, we need two scalars, two separate scalars, because when we use a scalar needs to be fit on data. Okay, so position level and salaries are two different columns. Okay, two different entities. So we will be needing two different scalars. So here create two scalars, scalar 1 and scalar 2. Okay, and name them scalar x and scalar y. Okay, so we have created two scalars, and after creating these two scalars, now we can fit and transform. We can scale value of x and y, okay, by calling fit and transform. So scalar x dot fit transform. Okay, so it will first fit the scalar and then transform the values of x. Okay, pass x and then assign result to x. Y equals to scalar dot fit transform scalar y dot fit transform and pass y. Okay, so here in this statement we are scaling x and assigning result to x, and in this statement we are scaling y, okay, and assigning result to y. Now run this cell. Okay, now add two cells, print x and y both. Print x, and if you see, okay, these values are scaled values. Okay, so now we have perfectly scaled values. Values of x are in the range of minus 1.56 to 1.56. Okay, so this minus 1.56 corresponds to what? It corresponds to 1. First element, first value is 1. So 1.56 corresponds to 1, and 1.56 plus, okay, this corresponds to 10. So this is ranging from minus 1.56 to plus 1.56, and value of I, print y, value of I are ranging from minus 0.72 to 2.64. So these values are in the range of, you can say, minus 1 plus 3. Okay, so this minus 0.72, it corresponds to what? 45,000. And 2.64, it corresponds to 1 million. Okay, this value. So now we have perfectly scaled values. Okay, now this y is 2D array, x is also 2D array. Okay, x and y both are 2D array. And next step, we will train SVR model on the data set. Now we will use SVR. We will actually create SVR model. So from scikit-learn dot svm support vector machine svm import SVR support vector regression, and create an object of SVR, instance of SVR. This SVR class, okay, accepts kernel. Okay, we will discuss kernel in detail, okay, later on. So you can specify kernel. We will be using RBF kernel. RBF is radial basis function. Okay, so we have linear, we have poly, we have sigmoid. Okay, we will be using radial basis function kernel. Set it to RBF and name it regressor. Okay, so we have created an instance of SVR. Next, call fit method on regressor. Okay, train this model. Regressor dot fit and pass x and y. So currently y is 2D. This is 2D array. It is 2D array, right? So currently y is 2D array. Now if we run this cell, okay, it might give error. Let's run this to see if it works. Yes, it is giving error. Error says what? A column vector y was passed when a 1D array was expected. So for feature scaling, features we actually transformed y from 1D array to 2D array. But for now this model training, okay, for fit, okay, we need 1D array. This y needs to be 1D array. So here we can add one more cell and reshape y to 1D array. Okay, so to reshape y to 1D array, what we can do is we can write y dot reshape. Currently it is 2D array, so y dot reshape and pass len of y, length of y. Okay, and y equals to, assign this to y. Run this cell, print y again to see what is there in y, print y, and now if you see, it is 1D array. Okay, so we have transformed this y from 2D array to 1D array. Now it is 1D array, right? Now run this cell again, this cell again. Okay, so earlier this cell, when we tried executing this, okay, this gave error, this returned error because we supplied y which was in 2D array form. Okay, run this cell again, and now cell executed successfully because now y is 1D array. SVR, support vector regression model, has been created and trained on x and y. Now after building this model, okay, we can use this model, okay, for prediction. So next step is predicting a new result with SVR. Add a new cell. So here use this regressor. This regressor is trained model. Okay, regressor dot predict, and this predict requires what? Okay, if you remember, in last session we tried to predict salary for 6.5 years experience, right? For a person, for a candidate having 6.5 years of experience. So here we can pass 6.5 in 2D array because it expects this x, because we trained this regressor on x and x is in 2D array form, right? So here we need to pass this x 6.5 in 2D array form, so in double square brackets. Okay, but here if you see here, before passing these values x, here in our data set x is ranging from 1 to 10, but before passing this x to this fit method, okay, for training this model, okay, we scaled these values. It means this 6.5 also needs to be scaled. Okay, this is in the range of minus 1.56 to 1.56. It means this 6.5 also needs to be scaled. So here what we can do is we can use the same scalar, okay, that we used here, okay, to scale x. So we used scalar x, okay, to scale x, and this is already fit, right? It is fit on x. So use this scalar x here to scale this value 6.5. Scalar x dot transform. Don't use fit transform because scalar x is already fit. Okay, that is already fit on x. So use only transform and pass this 6.5 in double square brackets. Okay, or you can try running this in a separate cell. Okay, let's add one more cell, and if you copy this and run separately here, okay, it will show you actually what it will be scaled to, what value it will be scaled to. So if you run this cell, now see it is in the range of, it is in this range, minus 1.56 to 1.56. Now its value is 6.5. After scaling, it is 0.34, right? So here, this part, this will scale the 6.5 and then scaled value, pass this scaled value to predict method. Okay, so run this. And if you see here, this is minus 0.27. This result is also scaled because we trained this model on scaled x, scaled y. So it will give you scaled result. This is scaled result. It means now this scale, to get the original value back, the value back from this scaled value, scaled result. Okay, we need to do what? The inverse transformation. Okay, so here let's assign this to pred result, predicted result. Pred result equals to. Okay, so this will be assigned, this 1D array will be assigned, means this G minus 0.278661, it will be assigned to pred result. Run this cell and now add one more cell and let's print pred result. Okay, and we have this value minus 0.2786. But this is scaled value, and to get the original value back, okay, from the scaled value, we need to use inverse transform. Okay, we need to do the inverse transformation. So add a new cell here, and to get the value back from this, because this is y, predicted y actually, and we used scalar y, okay, to scale y. So this scalar y is, we actually, this was fit on y. Okay, so we can use scalar y to transform this value back to the original value. Scalar y dot inverse transform and pass pred result. Okay, scalar y dot inverse transform and input pred underscore result. So this pred underscore result is 1D array. Okay, single value. This 1D array has single value. Okay, run this and it is giving error. Okay, error is, this is value error. Why value error? If you remember, here for feature scaling, we converted this y to 2D array. So this was trained, for training this, for fitting this, actually we use this 2D array. It works on 2D array actually. It expects 2D array. And here we are passing 1D array, right? We are passing 1D array. It means in this case, this pred result needs to be transformed, converted into 2D array. So to convert this into 2D array, what we can do is we can use reshape. Okay, and 1, 1. 1 row, 1 column. It means single value. Okay, not here. Convert this here. Okay, or you can add one more cell here. Okay, if you want to do it in separate step. Pred result dot reshape, run this cell, and if you see, now it is 2D array. This value is enclosed in double square brackets. Okay, so you can assign this to pred result again. Pred result equals to, okay, and if you run this cell, this pred result will get transformed into 2D array and the result will be assigned to pred result. Run this cell and we print it again. Okay, let's print this again. And now it is 2D array. If you see here, now it is enclosure double square brackets. Now pass pred result. Okay, input pred result to inverse transform now. Run this cell and now it is giving value. Okay, 1,70,370 and you can assign this to pred result again. Run this cell and then print pred result. Pred result. So this is the predicted salary, okay, for a candidate having 6.5 years of experience. So if you are interviewing as an HR, if you are interviewing a candidate having 6.5 years of experience, okay, you can use this model, okay, to find out, to determine how much should be the salary of this candidate. Okay, so it is predicting that this person who is having 6.5 years experience, okay, the asks or the salary expectation should be 1,70,370. Okay, so this is how you can use this SVR model, okay, for predicting new results. Now next step is visualizing the SVR results. Okay, here. So let's use plt dot scatter to plot data points, and we want to plot x, we want to plot y, and color equals to red, set label to data points.